welcome to Maths with Bob. Today we're looking at applications of calculus to the physical world, growth and decay 4. Now I'm actually titling this one The Life of Brine, actually, because I'm going to look at some salty solutions in a couple of different scenarios with basically big vats of water which becomes salty, or salty water that becomes more salty, if you like. So the first one, let's actually have a look at a situation. We have a big vat, okay, of water. Say it has about 300 litres in it. And this is going to be just pure water, so there's going to be 0 grams of salt in it. Okay, we're now going to make it salty by pouring in some water. Obviously the inflow rate would be, let's have a look. Okay, let's make it 9 litres per minute. And the salt content would be, say, about 2 grams per litre. 2 grams per litre. Okay. The outflow rate obviously is the same for these exponential growth and decay questions. So the outflow, okay, would be actually 9 litres a minute. Okay. Okay. And after some time, the amount of salt would be, say, Q grams of salt in there after a certain amount of time, and the concentration would be what, Q over, say, 300, because there's 300 litres, that's grams per litre. That would be how much it would be coming out. And you can see that the actual decay would be, what, 9Q over 300. The L's that goes going to be coming out is 9Q over 300 grams per minute. Okay, which is about 3 on 100. Okay, so how do we set these up? Well, as I said, the usual way I normally set them up originally was you set up a flow like the rate of change of the amount of salt. I'm going to let it be Q dt is equal to what? Inflow minus outflow. Okay, we'll do the other technique, steady state technique, shortly as well after this. Okay, so basically, how much is flowing in? Well, if you have a quick look there, if you do some calculations, you can see it's 9 times 2, which is 18. Okay, there's going to be 18 grams of salt flowing in. Now, how much is flowing out? Well, you can see we did that calculation. It would be actually 9Q over 300, which we will simplify shortly. Okay, well, let's rewrite this as what? Let's have a look. Sorry. It should be 18 minus 3Q over 100, and this would be what, 1800 minus 3Q all over 100. Okay, that'll be what, dq dt. And we turn it upside down. Okay, so we'd end up getting something like what, dt dq is equal to 100 all over 1800 minus 3Q. And now we have to integrate both sides with respect to Q. Okay, so let's actually do that. Okay, so we're going to now, okay, rub out some of this, and we're going to just set up the equation. Okay, so what do we do? Well, obviously, in the integral of dt dq with respect to Q is the integral of dt, which is going to give us the time. Now, this one, okay. What is the integral of this? Now, there are a few things. Okay, let's take out the 100. And we're going to get the integral of 1800 minus 3Q in respect to Q, dq. Now, you might remember logs. We do need, I'll just put this in red here. We do need a minus 3 here, so that turns into a log. So we need to divide by minus 3 at the front here. So you can see here we need to adjust this integral slightly, and we end up getting what? T, we integrate both sides, and we amalgamate the constants onto one side. Okay, so it's 100 on minus 3 ln of 1800 minus 3q plus some constant c. Move the constant over, we end up getting what? T minus c is equal to this expression, 100 on minus 3. Okay, ln 1800 minus 3q. Now we multiply everything by well, minus 3 on 100, I guess, to get rid of that 100 on minus 3. So we end up getting that, if you like, minus 3 on 100 T plus 3C on 100 is equal to ln 1800 minus 3Q. Okay, now we're going to raise everything to the power E. Okay, so basically what we do now is we go, okay, let's just rub out a few of these things. Okay, let's just leave that bottom line there just for a minute. Okay, so we can just follow on. Okay, so what happens now? Okay, everything to the power E, so we end up getting E to this minus 3T on 100 plus 3C on 100, yeah. Okay, it's supposed to be 100, okay, is equal to what? E to the ln 1800 minus 3Q. Now, hopefully we know these are inverse functions, and this is going to drop us out at 1800 minus 3Q over here on the right. Now, this is going to just, we're going to just have an expression here, e to the minus 3t on 100 times e to the, 3c on 100. Now, that's obviously a constant. So this is actually a constant, this bit here. This is going to be a constant, and we normally would let that be some value, which we're going to find out shortly. Now, okay, so let's actually try and find that value out. Now, in this particular case, t is equal to 0. Actually, we have 0 amount of salt. Okay, so we have that Q actually is actually equal to 0. Okay, 0. Okay, therefore 1800 minus 3Q is 0. Well, sorry, no, sorry. 18 minus 3Q when Q is 0 is 1800. So the amount of salt at this particular time is 0, but the actual constant itself turns out to be 1800. So we end up getting, therefore, e to the 3c on 100 is 1800 minus 0, which is just 1800. Okay, so we end up getting this constant being 1800. So we now need to rewrite the equation. Okay, so let's rewrite the equation. Let's see what happens. Now we have, so we basically have 1800. Okay, that's replacing this one here. Okay, with 1800. Okay, so we then can see here this would be, we've still got e to the minus 3t on 100 here, and that's equal to what? 1800 minus 3q. Now we need to make q the subject, so we put the 3q on the other side. And let's actually divide by 3 as well. Okay, so what happens? If we divide by 3, obviously we get what? Q on this side is equal to, now, okay, we get 1800 divided by 3, which is 600. Then we get 1800 again divided by 3, 600, e to the minus 3t on 100. Okay, this is now going to be our equation which we work with. And we're going to try and work out the time when there is about 200 grams of salt in this solution. Now you can see here, as time goes to infinity, this particular term, okay, like a transient sort of situation, this particular term here would actually go to 0, and basically we're heading towards about 600 grams of salt in our solution eventually. Okay, so let's actually try and work out now, say the time it takes for the concentration to come up to about 200 grams in that 300 litres. Okay, so let's try and do that now. So, okay, so what we need to do is, I'll just write out some of this, okay. We're after the time, so I'll just leave this last equation here. Okay, so we're after the time. Okay, so we need the time, question mark, when Q is actually equal to, say, 200 grams of salt in the solution. So we now need to solve this, therefore, 200, okay, is equal to 600 minus 600 e to the minus 3t on 100, okay. So we're after that t up there, which is a bit hard to see at the moment. So let's put the 600 on the other side. We end up getting, what, minus 400. Let's divide it by minus 600 as well. And that's going to equal e to the minus 3t. This is the t we're after on 100. So you can see here, this is going to equal, what, 2/3. We need to take the logs. So this is, so let's just take the logs. So ln on the left here, this becomes 2/3 equals, let's take the ln's of here, we get obviously the ln of e to the minus 3t. This is how we get these powers down, remember, using our log laws. And let's just run out some of these things down here. Okay, so this is obviously equal to minus 3t on 100. Okay, ln e, which is, is 1. And this is ln 2/3. And from here we can get the time is, you can see here, is equal to, if you like, ln of 2/3 divided by minus 3 on 100. Now, okay, so the top is negative and the bottom is negative, giving us a positive time, and the positive time is about 13.515 minutes, so about 13.52 minutes. Okay, so it's about 13.52 minutes, okay, to dp. So that's how long it takes for the concentration, if you like, or the amount of salt, I guess you could say, to build up to 200 grams. Now, this is actually pure water to start with. Okay, well, now let's have a look at another scenario when we actually have a bit of salt in the water. Okay. Well, okay, just before we go on, let's actually, before we put actually a bit more salt in this solution and have a look at another brine problem, we'll actually look at the solution to this using what's called the steady state idea. And the steady state idea was that the amount of salt, or whatever it happens to be, is equal to, it could be syrup or whatever, is actually R. Now it becomes minus A e to minus k t. Now, the R was the actual steady state here. This is the steady state here. And this is, you can see here, so Q would be equal to, what is it approaching? Well, if you think about this, 2 grams per litre are coming in. There are actually 300 litres. So that would be actually 600 grams of salt eventually, 600 grams. So we eventually get 600 grams here. Now, A was the difference between the steady state and the amount present initially, and you can see that's because it's 0, it's to be 600. E, okay. Now, K, what was K? What was it decaying at? Well, if you have a quick look, I'll just rub out a few dots here. If you have a look down here, down the bottom here, you can see it's actually decaying at about 9/300, or if you like 3 on 100 actually grams of salt per minute. Okay, so it's actually the K, okay, is actually minus 3 on 100 and T, okay, for the time. And you can see here this is the same sort of equation we arrived at doing the inflow and outflow. Okay. All right, so let's actually now move on and put some salt in our solution. Okay. All right, so what will we do? Okay, so let's actually change the amount of salt in the solution, okay, to say, okay, instead of 0, let's actually put it up to say there's 50 grams. So there's 50 grams in our solution to start with. So let's actually go through the situation now. Rather than having pure water in our tank, let's actually just say it's actually a brine solution already, and then we try and increase the concentration. Now, how do I know whether I'm going to increase the concentration? This is another question that comes up sometimes. Increase the concentration or decrease the concentration. Now, we know that 2 grams per litre is coming in. So what is the concentration at this point in time? Well, you can see here there would be, 50 grams over 300 litres. Okay. So the concentration, okay, would be roughly, you can see here, 1/6 of a gram per litre. Now, you can see here that's quite a weak solution actually present at this stage, and we are putting in a fairly concentrated solution of 2 grams per litre. Okay, so let's actually go through, dq dt, remember, was equal to what? Inflow minus outflow. And the inflow again is just, you can see here, twice 9, 18, that's okay, that's the same as before. The outflow again is the same really. It's the only difference you can see here is going to be the constant. Okay, so what are we going out at? 3q over 100. And again we go through this process Okay, this is dq dt. We have to turn it upside down to get okay, dt dq. Okay, and make that 1800 minus 300. So let's actually put that on the bottom. So we end up getting, okay, we turn it upside down. So I'll do a few steps at once. So this is going to be 1800 minus 3q, which was on the top. Now it's going to be on the bottom. So it's 1800 minus 3q. And we have 100 on the top. And you might remember we had to integrate both sides with respect to q. We had to watch it a little bit. We end up getting t here. But you might remember this was, we had to have 100 out here. We had to integrate this dq over, you might remember this 1800 minus 3q, but remember the derivative of the bottom is actually minus 3, so we put in a minus 3 here, we divide by a minus 3 here, and then that gives us the log answer. So let's quickly, okay, let's just leave this here, and we'll just quickly go to the part which is slightly different, which is just the constant you'll see in a second. Okay, so all right, okay, so let's actually see, well, first up, what do we do? Well, let's quickly just do this. T is equal to, you can see here, 100 on minus 3, ln, and this becomes now 1800 minus 3q, plus a c. We can do a few things here, but I'll normally just put the c across. T minus c is equal to what, 100 on minus 3 ln again, okay, 1800 minus 3q, multiplied by minus 3 on 100, you get minus 3t on 100, plus 3c on 100, this is just a constant, is equal to ln this, okay, 1800 minus 3q, and then you raise everything to the power e, and then you end up getting what, e to the minus 3t on 100 times e to the 3c on 100 is equal to what, e to this becomes 1800 minus 3q. Now, when t is equal to 0 now, okay, so let's actually look at t is equal to 0. This is where the difference really comes in, okay, because the constant now, there is actually 50 grams there present, okay, before there was actually 0. So let's have a look. So if t is equal to 0, okay, t is equal to 0, well, q, as you can see here, q is 50. And as you can imagine, 3q is 150. So therefore, when t is equal to 0, e to the 3c on 100 is just, what, 1800 minus 350s, okay, 150, okay. And you can see here, what's that going to be, 1650, okay, so that's, okay, 1650. So this is now going to be our value of our constant here. Okay, so let's have a look. Now, okay, so how do we rewrite the solution? Let's rewrite the solution. Okay, so let's rub this out here and just rewrite the solution. Okay, okay, so what is the solution? Well, let's have a look. Well, you might remember if we actually put this is a constant in, so we have what? 1650 e to the minus 3t on 100 is equal to what it was, I think, 1800 minus 3q. Okay, now we need to rearrange this. Okay, so what do we get? 3q is equal to, put that on the other side, 1800 minus 1650 e to the minus 3t on 100. Okay, let's actually just divide by 3. This 600. This is going to be 600. This is going to be 1650. I'll just write that at the moment. 1650 on 3. Okay, e to the minus 3t on 100. Okay. Now, you might remember we were after a time when there was about 200 grams of salt. There's 50 grams to start with. So it's obviously going to increase over time. So let's actually try and solve that now as well. Okay, so we want the time when the actual quantity of salt in this big vat is actually 200. So basically we're going to do, okay, what do we want? We want the time is actually question mark. And we know that Q is going to equal 200, so we need to solve 200 equals 600 minus 1650 on 3 e to the minus 3t on 100. Okay. Okay, well, luckily 1650 on divided by 3 simplifies, so we end up getting 200 equals 600, now minus 550, that's e to the minus 3t on 100. Okay, so how do we solve this? Well, obviously we put the 600 on the other side, so let's actually go through how we solve this. So let's just solve all this. Okay, so what do we get? 200 minus, well, 600 on the other side becomes minus 600, so it's minus 400. Let's divide it by the minus 550 as well while we're here, and that is going to equal what? E to the minus 3t on 100. Now, obviously we're after the time. Now, minus 400 on 550 just turns into 8 and 11, so this would be what? So let's actually take the logs as well. So ln of, this becomes 8 on 11, okay, equals, now the ln of this, as you might remember after doing a few of these, the power comes down, minus 3t on 100. And you can see here the time, which we're after, let's have a look at the time, would now be equal to, okay, it's ln 8 on 11, all divided by minus 3 on 100. Okay, which roughly works out to be, I think, about 10.62 minutes to, okay, so 2 dp. Now you might remember the previous example where that was actually pure water was about 13.52 minutes. Okay, so as you can imagine, it should be a bit quicker because there was some salt present. Okay, well, this is a fairly long one, and thank you for watching. Bye for now.